Hello, welcome to the course of computer networks. So today we are going to discuss about the IP packets. So in this chapter we will discuss about what is IP packet. Next we will discuss about the IPv4 and IPv6 header format, and lastly we will discuss about the some of the terminologies linked to the IP packet. So starting with the very first, let's discuss about the IP packet. So here this diagram is displaying a IPv4 packet format which is consist of IP header plus payload data. Here the IP header is of 20 to 60 byte long, whereas the IP header plus payload data constitutes 65,535 bytes in total. So this diagram is showing a basic diagram of IPv4 packet format. In next slide we will discuss about the IP header format. So here this is the IP header format. Here this IPv4 packet header consists of 14 fields, out of which only 13 are used. Here these fields are like version, identifiers, the protocols, padding, fragment offset. So these are the fields of IPv4 packet format, and this packet is of 32 bits long. Let's discuss about these fields one by one. So starting with the very first, let's discuss about the version. So here this is a 4-bit field and it is set to binary 0100 for IPv4 packet and binary 0110 for the IPv6 packet. It means if this packet belongs to IPv4, then this version field will contain a binary set of 0100, and if this packet is of IPv6, then this version field will contain a binary set of 0110. Next is header length. Here this header length field will tell the number of 32 bits word in the header, or it will tell about the length of the header that we are going to use. Next is type of service. Here this field is used to carry information about the quality of service of IPv4 packet. Next is total length. Here this field defines the length of the entire IP address that we are going to define in source address and destination address. Next is explicit congestion notification (ECN) field. This field carries information about the congestion that is seen in the route. Next is identifier. So here this identifier field is used for uniquely identifying the fragments of an original IP packet. It means if the IPv4 packets have some fragments, then this identifier field will identify these fragments from the other packets. Next is fragment offset. This is a 13-bit long field and this is used to define the number of fragments of IPv4 packet. Next is protocol. So this field is used to indicate the protocol that is used in the data portion of IP packet. So the protocols like TCP or UDP are defined here in this protocol field. Next is header checksum. Here this field is used for error checking of the header and it is of 16-bit long. Next is source address. This indicates the IP address of the source of the packet or the originator of the packet. Next is the destination address. This indicates the IP address of the receiver of the packet. Next is flag field. Here a 3-bit field is used to control and identify the fragments, and they are like bit 0 is for reserved and it must be 0. Next is bit 1. This means there is no fragment present in the packets, and this means it defines don't fragment by df. Next is bit 2. Here this defined that there are more fragments and it is defined by mf. Next field is time to live field. Here this field indicates the maximum time for which a packet is allowed to remain in the internet system. And lastly is option. This is an optional field and reserved for the future use. Next, this is a IPv6 packet, and here this IPv6 packet consists of IPv6 header, extension header and upper layer protocol data. So these three together constitute and make the IPv6 packet. So let's discuss about the IPv6 header. Here the IPv6 header will have a fields like version, payload length, next header, source address, destination address and extension headers, etc. So you can see here like the IPv4 packet formats and IPv6 packet format are similar, but some of the fields are missing here, and it is also of 32-bit long. So let's discuss about these fields one by one, starting with the very first, that is version. Here the version is 4-bit long and it remain constant. It means it defines the value 6 or the bit sequence 0110. Next is traffic class. This field is of 8-bit long and this field holds two values, that is GS and ECN. Here the 6 most significant bits hold the differentiated services field, that is GS field, and which is used to classify the packets. Whereas ECN, here the remaining 2 bits are used for explicit congestion notification, and it gives the information about traffic in the route by defining congestion control and non-congestion control traffic. And next field is flow label. Here this flow label field is used for giving real-time application services, and it is also help to detect spoofed packet, and it is of 20-bit long. Next is payload length. Here when a hop by hop extension header holds the jumbo payload option, then the length is set to 0 and it is 16-bit long. Here the jumbo payload is a user data field that exceeds the IPv4 limit of 65,535 octet, and it is called the jumbo payload. Next is next header. Here the next header specifies the type of next header and it is of 8-bit long. And next another is hop limit field. Here they specify how many number of devices can be visited by the packet, and this field replaces the time to live field of IPv4 and it is 8-bit long. Next is source address and destination address. Similarly, here the source address indicate the source node and it is of 28-bit long, and destination address, it defines the IP address of destination node and it is also 128-bit long. Here the extension headers are like hop by hop option, source routing, fragmentation, authentication, encapsulating security payload, and destination option. According to their use, we will define this extension header, and these are optional field. Extension headers are added to IP packet to give greater functionality to these packets. Some of the terminologies linked to IP packets are like, first one is maximum transmission unit, that is MTU. Here the MTU is the largest packet or frame size that is specified in octet or 8-bit byte. It is sent in a packet or frame based network such as the internet, and here MTU is usually associated with the Ethernet protocol, where a 1500 bytes packet is a largest allowed in it, and here the TCP protocol use the MTU to determine the maximum size of each packet in any transmission. Next is fragmentation. Here the fragmentation divides the packet into pieces, and each piece is small enough to pass over the single link and defined MTU parameter. And here this process takes place when packet size is bigger than MTU parameter to pass through single link. So then the fragmentation of the packet is done, and this process takes place at the IP layer or the OSI layer 3 in IPv4. And the next is reassembling. Here the process of rearrangement of the original packet from fragment is called reassembling, and here the receiver knows whether an incoming packet is fragmented or not, and according to it the device performs reassembling, and it also checks whether all fragments have arrived successfully or not. So these are the three terminologies: MTU, fragmentation, and reassembling in IP packet. So this is all about IP packets. Thank you.